let's talk about Dr. Abby Hafer. Dr. Abby Hafer is the author of the book, The Not-So-Intelligent Designer, Why Evolution Explains the Human Body and Intelligent Design Does Not. So you can expect us to use words like evolution and not-so-intelligent design. And we're going to talk about organs and sacs that get infected in the human body. And she does a bunch of talks about this topic. She's been talking to the American Atheists and different humanist organizations. She gave a talk over at the Humanist Hub over in Cambridge, which I was not able to go to. So I contacted her and said, hey, I wasn't able to go to the talk, but how would you like to be on the podcast? And she graciously said yes. So we're going to talk evolution.
Yay. I like talking evolution. It's fun. Yeah, no, I caught some of her speeches on YouTube. They're very enjoyable.
She has a really interesting sense of humor. I'm not going to ruin it. I'm not going to ruin it for the listeners, Jack. They're just going to have to listen. They're just going to have to fucking listen to the fucking episode.
Yeah. So strap in.
Because nothing encourages people to listen to an episode than random swearing by one of the hosts. All right. We should close this out and get on to the meat and potatoes.
Indeed. Dr. Abby Hafer.
Hafer. What are you doing, Jack?
Dr. Abby Hafer.
Yes.
Dr.
Abby Hafer. She's on now.
Hi, how are you?
Hello.
I'm doing well. This is Jack. That is co-host Jack Baturka. He is the technical brains of the operation.
Ah, okay.
So, yeah, Dr. Abby Hafer, it's good having you on. You know, when I was growing up, there was creationism.
Mm-hmm.
How did it turn into intelligent design? How did that hat trick occur?
Politics, basically, and the desire for a profit. What happened was that, creationism, which at the time, if you're talking about, like, say, the 70s or the 80s,
yep.
Was referred to as scientific creationism. You may not remember that, but they were trying to sell it as basically a scientific alternative to evolution.
Mm-hmm.
And so the folks who were doing this, as I said, were trying very hard to get it taught in public schools as science. But then the Supreme Court, in a decision called Edwards versus Aguillard in 1987, declared that creationism is religion.
Mm.
So that took care of that. The only problem was, for the creationists, in addition to grave disappointment, was that they had a biology textbook in the works. That they had been working on a creationist textbook, and their idea was to sell it across the country to public schools, as a biology textbook. And as soon as creationism was declared to be religion, suddenly the market narrowed drastically down to, private religious schools, basically.
Sure.
Mm-hmm.
So, quite remarkably, and do you think it's a coincidence, they discovered intelligent design that same year. And so they then went and reworked that very textbook, known, I think, at the time as Of Pandas and People.
Right.
Basically, they reworked that textbook as an intelligent design textbook because, they said, whereas creationism was religion, intelligent design wasn't. Intelligent design was completely different from creationism. It did not start from the Bible and try to sort of square biblical stories with science. It was just something completely different, and they just said that there appeared to be a creator, and of course they wouldn't say who that creator was, but we all know.
Mm-hmm.
But there appeared to be this creator, and there was such, important evidence that there was a creator that they invented this field called intelligent design, reworked the textbook as an intelligent design textbook, but tellingly did not change the content. So as a result, they basically just went through and excised the word creationists and put in the words design proponents, and excised the word creationism and put in the words intelligent design. And this was actually proven mathematically in any number of ways because people were able to get hold of sort of early and late drafts of this textbook. And not only did they find, passages that were exactly identical in both, in fact, most of them, even, very often in the course of writing a book, your early drafts don't resemble your late drafts very much. But
Sure.
in this case, the content remained the same. There were a lot of telltale passages that remained the same, but the real killer was a telltale phrase. There was one time when they excised the word creationists, but they did not do it completely.
Really?
So this is a famous little piece of evidence where they took out the word creationists but did not do it entirely, and they inserted the words design proponents according to the protocol, which led to the classic smoking gun of the phrase, I'm not joking, see design proponentsists.
That's great.
And this and that obviously made it clear that it had just been a cut and paste job. I talk about this in my book. My book, by the way, is called The Not So Intelligent Designer. And one of my chapters deals with this very thing because see design proponentsists is just so beautiful and so laughable.
Oh, yeah.
But it is far from being the only piece of evidence that that's what was going on, but it's just kind of a lovely one. And it is sort of coincidentally and ironically a lovely example of a transitional species.
It's also evidence of a not so intelligent document production formatter.
Right. Well, that's the problem. I mean, they did try, but they didn't succeed. And I mean, there are a lot of people trying, and they're paid pretty well to try, but they don't do everything right.
Right. So, do people ask you, because I know that you teach over at Curry College, you teach, from what I understand, human anatomy and physiology.
Right.
Do you teach a lot of freshman level classes, or?
Oh yes, that's basically it. I mean, I do teach other courses there from time to time, but anatomy and physiology is a very heavily subscribed course because many people want to enter the nursing program at Curry College,
Sure.
And all of them are required to take human anatomy and physiology first, and so. The vast majority of my students at Curry are freshmen or first-year students who wish to become nurses.
Does intelligent design creep into any discussion with the students
Rarely.
in the classes? Really?
Very rarely. I remember one time a student very politely asked me about this, and this was just from the standpoint that when I teach, I very often, point out cases of bad design, and I point out cases of kind of amazing things that happen just because of chemistry. I mean, we're not even up at the level of biology, but it's like cell membranes kind of put themselves together because that's what phospholipids do in water. Anyway, so the point is that I had this one student who very politely asked me one time about, so evolution, but, what about the Bible? And
that's a softball right there.
Yeah, I mean, he was being nice.
Oh, yeah.
And so what I told him was that if you do not take the Bible literally, then you're okay with evolution. And I pointed out that, in fact, most mainstream Christian denominations accept evolution. But on the other hand, if you are a biblical literalist, then you have much bigger problems than evolution. For instance, the Bible talks about the four corners of the earth. Well, do you really think that the earth is a rectangle?
Right.
So that was the example that I used. And, every now and then I've had a student just sort of say, well, but what if you don't believe in evolution? And I basically say, well, it's true anyway.
Right.
Just kind of leave it at that. It is an anatomy and physiology course. That's what I'm teaching them about, and that's what I'm testing them on.
Right.
But anatomy makes so much more sense when you explain it as, the outcome of evolution. It just clears up a lot of things. Like when people ask, "So, what's the appendix for?" and I can say, "Nothing. It's really lousy. No purpose to it at all. It's just an evolutionary leftover, and that's actually much better for understanding."
Yeah.
Than trying to figure out why it is that we have this thing and all of that kind of thing. It just makes many things much clearer.
Sure. So my appendix almost ruptured when I was 10 years old.
Oh, my goodness.
Yeah, I was in the ER waiting room for hours and hours, writhing in pain before they got me in. They took a look at me and basically rushed me into surgery. So tell me what happened to my appendix. Why did it misbehave?
Okay, what happened is that the appendix is a blind sac. And in fact, it's a blind sac off of another blind sac. And it's a rather skinny little worm-like or worm-shaped blind sac. In fact,
what do you say blind sac? Can I ask you what that means?
It means it has one entry.
Okay.
Think of like the tube of plastic that your newspaper comes in if you actually read newspapers. That's a blind sac. It has one opening and then it's closed after that. Your average paper bag is a blind sac.
Sure.
And in fact, the appendix is, as I said, a blind sac off of another blind sac, and it is this peculiarly long, sort of worm-shaped blind sac. That's why its official name is the Vermiform Appendix.
Interesting.
And biologically speaking, and this is where talking about biological principles suddenly makes everything much more clear. Biologically speaking, where things flow, you will have fewer bacteria. This is why fast-running water is going to be less full of bacteria than water at the side of a stream, for instance.
Sure.
Flow just discourages bacterial colonies.
Mm-hmm.
And so when you have a blind sac off of a blind sac, you have the perfect place for a bacterial colony. Couldn't be better.
So that's a swamp. My appendix was a swamp.
Yeah, basically. And the problem was it was a swamp where even that one little exit got blocked somehow. So the bacteria bred up and then they had no place to go. So they tried to burst out and you were in a lot of pain because your appendix was swollen and things got really ugly.
Yes.
So that's what was happening to your appendix. And it makes sense in other animals that digest wood, like rabbits or koala bears or, all kinds of other animals that digest wood. That appendix and the cecum, which is the blind sac that the appendix is off of, they actually are much larger. They're well-developed organs that have lots of bacteria in them, and that is where wood gets digested down to usable molecules that the animal can then, digest, eat, absorb. Right. And so in other animals, the ones that digest wood, the appendix is actually this really huge, remarkable organ, but it's just, we gave up trying to digest wood a long time ago. And so the appendix over time has, become less and less obvious and visible, but it hasn't gone away completely. And so we are unfortunately stuck with this little thing that, were we rabbits, it would do us a lot of good. But in fact, because it is now this evolutionary leftover, we're just kind of stuck with it, and every now and then it kills us. Which is very bad design.
It's very bad design.
Does that make sense?
That makes total sense. Thank you.
Good.
Thank you. Now I can explain it to my kids in case they ever have to get their appendix taken out. And as they're writhing in pain, I can just explain to them the intricacies of eating wood and blind sacs. Right.
So the short version there is that where something is flowing, you will have fewer bacteria.
Right. That's good. That's a good takeaway. So when we'll play a game. I'm going to say a phrase, and then you can tell me what first comes to your mind, and just Talk about it. So if I was going to say the term intelligent design science, how would you respond to that?
Okay, so you want to talk about intelligent design science. Well, of course, the first thing that comes to mind is contradiction in terms, because intelligent design is not science. This is one of the biggest, most important things to understand, actually, because what the folks who are pushing intelligent design are trying to do is get it taught as science in American public schools. Mm-hmm. And it's really religion. So it is a bad idea on both counts. First of all, you shouldn't teach something that is not science as science. And second of all, of course, we have the Establishment Clause in the U.S. Constitution that calls for separation of church and state. Public schools are a part of the federal government, or of the government, and so therefore we are not supposed to teach any kind of religion in public schools, and that includes this sort of pseudo-science that's really religion is sort of a wolf in sheep's clothing routine. Intelligent design is basically masquerading as science because its proponents want it taught in public schools because, of course, most Americans get taught in public schools. So they see this as sort of the first part of their grand scheme to make America live by biblical edicts. And of course, they will decide what biblical edicts we should live by. But the point is, they see this literally as the thin end of the wedge for getting their version of religion into public schools. Right. So they do it by calling it science.
And intelligent design has no predictive ability to say that, to make any kind of predictions about what's going to happen in the future, unlike evolution, which can say under certain circumstances, this is probably what's going to happen.
Oh, you got it in one. Absolutely. And this is one of the things that I point out, is that intelligent design cannot make predictions. Even its proponents concede that. And so in science, science is just a method of investigation, and then this assemblage of facts that are the fruit of this method of investigation. So one of the things that scientists have to do, yes, there's observational science. You take data, you look at something, you write down what you see, and so on. But at some point, as a field develops, you have to start doing it with numbers. You can't just say, gee, there are a lot of penguins on that island. You have to say, how many are there? What species? Where do they live? This kind of thing. And at that point, you're starting doing things with numbers. What I'm getting at is that whether you do observations or whether you do laboratory experiments, there will come a point in the development of a field when you have to start making predictions. You have to climb out on a limb and make a prediction, and a prediction that can be falsified. So that you can be proven wrong. And a lot of times scientists are wrong. That's why we do experiments, and that's why science goes so slowly, is because we go through this very, very careful procedure for testing every last little kernel of knowledge that we think we've got. But on the other hand, it does mean that, occasionally our predictions are right and we make some progress. Whereas intelligent design does not make any predictions at all. It can't. It actually can't.
And it makes no progress then.
So it never makes progress, which is why, although science moves very slowly, and in fact, discussing philosophy and religion can seem much more productive because you can actually get somewhere by the end of an argument. Somebody won, somebody lost, maybe people had some good ideas. But over the course of time, science actually is the one that makes real, actual, measurable progress. To this day, you and I could have a perfectly good argument about, communism versus capitalism as economic philosophies.
Sure.
or we could argue about lots of other things that philosophers argue about. But at the end of the day, we would have had a really good argument and not much more. Whereas, in the past several hundred years, while people have been having those philosophical arguments, in science, we have discovered vitamins, and we have figured out about immunity, and we have, with the help of, I won't say with the help of technology, but by assisting the development of technology, obviously we've come up with things like Skype that we're using right now and sent rockets to the moon, and people using biblical physics just couldn't have done that.
No.
So,
wait. Is there a field of biblical physics?
No.
Okay. Because that would
we could probably comb the Bible and find something.
Yeah.
But the point is that science, to be science, has to occasionally make predictions, or it's not science. And intelligent design just plain can't do that. So, it fails on that count alone as well as on others.
Sure. How did you become such a passionate proponent of what you do, basically debunking intelligent design and talking about evolution? What was your calling? Was there a moment that?
Well, I would say there were several moments that happened. Very early on, when I was a graduate student, I was at UCLA at the time, and this was in the early 80s, and creationism was a thing out there, and there were actually, school boards in Los Angeles that were deciding to teach creationism. And this was the first that I had heard about that. I had been getting a good biology degree at a good college and, basically attending to my studies and trying to keep up with what was going on in the world, but I had absolutely not heard of creationism. And then get out to California and in Los Angeles. Now, we're not talking about the backwoods of Appalachia or anything like that. We are talking about a major metropolitan area, and they are seriously discussing teaching creationism and deciding to teach creationism. And I was just flabbergasted by this. But at the time, I was a graduate student, and there really wasn't anything I could do about it. But I thought that this was terrible, and I do think that it affected my studies in the sense that if you say, hi, I'm studying evolutionary biology, lots of people will say, what for? Why is that a field? So anyway, then I went on to Oxford and again kind of attended to my studies. But when I got back to the U.S., well, creationism hadn't gone away. It had become intelligent design, but it hadn't gone away. And it kept persisting, and and it annoyed me more and more that they kept having success with it. And then there was one time when I was having an interesting conversation about evolution with some friends of mine who are not biologists. And one of them asked, well, so when are we going to have enough evidence to just, put intelligent design away, just get rid of it? Well, he didn't know. So I just said, You've got the evidence. We've had the evidence for years. We've got libraries full of evidence. And he just didn't know. And he's a well-educated guy. He's an engineer. But he's not a biologist. So he didn't know that. It was an honest question.
Oh, yeah.
But I was surprised that people didn't know that. So that was sort of a wake-up moment, I guess. And then in that same discussion, I think that same individual then asked, well, so, why is intelligent design still around then? And another friend said, politics, basically because it's a political issue.
Yep.
And that made a light go off in my head. Oh, right, it's a political issue. That's why it's sticking around. It doesn't have to do with scientific evidence. It has to do with the fact that there are people who are very adept in the political arena who want this to happen.
Yeah.
So then it's all, and I also just thought, well, no wonder we're not doing well. Scientists are lousy at politics.
True.
It goes against our very training, because our training is to not put our personalities into our research, to let the facts speak for themselves very dispassionately, to basically stand aside and indeed let your colleagues tear your work apart so that, the hope for result is that in the end, those little teeny kernels of facts that we get are pretty reliable. But, that's just not the way that politics works. And scientists are not taught how to speak in the political arena. And so I just kind of thought in the back of my head, well, what would a political style argument for evolution look like? And I've worked on a lot of political campaigns, so I kind of knew the parameters. The parameters were the arguments had to be short.
Yes. Yeah.
They had to be easy to understand, easy to repeat, easy to remember, preferably kind of catchy. This was what we were looking for. And I had no idea what a political style argument for evolution would even look like. But that was just kind of the assignment that I gave myself, was to figure that out. And it's not an assignment that I worked on terribly hard. Sure. It's just what I was thinking, okay, this is what it should, these are the parameters. What can I come up with? And then there was one day when I was teaching anatomy and physiology, and I was literally standing up in front of the classroom, and we were talking about the male reproductive system.
Right.
And I had just drawn it on the board, and I was talking about the testicles, and I pointed out that the testicles hang outside the body, unlike all the other organs that are safe inside something. And so I asked the class if anybody knew why this is the case. Usually somebody does, and indeed somebody did. And so somebody, raised their hand and answered that this is to keep the testicles cooler, because sperm cannot be produced at normal human body temperature. And as I was turning around to write this piece of information on the board, I thought, that's really stupid. And alarms went off in my head, and I knew that I had my perfect first argument against intelligent design in the human body, because I knew that once I started talking about testicles, people would pay attention.
Indeed.
So I knew that was my lead-off argument, and what's more, I then kind of I could see a way forward in writing about it. So at that point, yes, next good part. I actually do go to a church. I go to a Unitarian church, which is very nice. I personally am an atheist, and I'm out about it, and everyone is fine with that, and my voice is valued, so I'm happy there. But anyway, there is a thing that many churches do called Evolution Weekend. You've probably heard of Darwin Day, right?
Yes.
Darwin
Day, of course. Right, definitely.
Okay, what a lot of churches do is that around Darwin's birthday, they will actually have a service having something to do with evolution. This is known as Evolution Weekend.
Interesting.
Okay.
And so our church was participating in this. And the service had actually been put off several times. It's like we had been snowed out and all kinds of other things like this. But anyway, as I am driving home, I am having this hilarious conversation with myself. And I am thinking, the Darwin service is coming up sometime. I really must write my minister about this. So I composed this hilarious email to my minister about why testicles are the first best argument against intelligent design in the human body. And I closed it with something like, who was it who said that when you've got them by the balls, their hearts and minds will follow? So anyway, I thought that this would just be something that, it would help him understand, because there are some actual deep points there having to do with bad design in the human body. I figured this would just kind of help him understand things, and that would be nice. Little did I know that he would repeat my email pretty much verbatim from the pulpit on Sunday and identify me.
Nice. Nice.
And people really liked it. People understood it. They had the kind of reaction that, I now know is likely to happen.
Sure.
And it was great. And I did just then think, okay, there is something to this. So I did a few workshops on evolution. And then as that was going on, I started developing a more sort of punchy style of delivery. Again, with the idea that this could be used as entertainment rather than just as sort of a scientific seminar.
Right.
I think the first time that I gave sort of the improved, witty and full of slides version of the talk I do called Unintelligent Design, I gave it at a faculty dinner. And it was totally perfect for that. And then basically, I don't know whether I discovered them or they discovered me, some of both. Anyway, I discovered the secular movement, and it turns out they really care about this.
Yes, indeed.
So there I was with a ready-made debunking talk, which is very funny and accessible, and I really wanted to take it on the road, and it turned out that the secular movement wanted me to take it on the road.
Cool.
So that's kind of how it all happened.
Sure. I was thinking about testicles just now and about how they need to be cool to make viable sperm.
Right.
And I can imagine a lot of young guys thinking, I just got to get put a sock in my pants.
Right.
And maybe that'll be some kind of birth control. But that's probably not the takeaway we want to leave.
Well, probably not, although there is certainly evidence that, say, professional bicyclists have fertility problems.
Interesting. And that's from the heat, not from any kind of friction or anything like that.
Well, the pressure probably doesn't help, but it appears to be largely heat. Yes.
Interesting. And the other thought I had is that, the testicles being on the outside of the body is not evidence for intelligent design, but it could, or an intelligent designer. But I think you can make a case for a malicious designer.
Well, that is true, and I do that is in fact one of the routes that I go in a lot of my reasoning, is that I say, okay, well then suppose this designer did that on purpose. What does that say about his or her or their personality anyway?
Yeah, nothing good.
Of course, if we're supposed to be made in God's image, it also makes us wonder. And yeah, there's the occasional business of either malicious or incompetent,
right?
Either of which sounds like somebody who could create the universe. I mean, if you can create the universe, wouldn't you think you could get a few things like that right?
Indeed, I would think so.
And the other thing is that, in fact, there are many warm-blooded animals that do have internal testes. So it turns out that it can be done. It just wasn't done for humans.
Nice.
It was done for elephants and rhinoceroses and marine mammals. So there, it is possible. Birds, by the way, have higher body temperature than we do, and their testes are internal. So it's just the case that, the creator didn't do that for people. So what's going on with that?
I could see an intelligent design paper being written about how the testicles were originally inside the human body at one time, and then original sin, that's what made them drop.
My goodness.
See, I was just thinking that the argument they'd go with is that since being naked is a sin, put them on the outside, so we were forced to cover up.
There's an interesting thought. Now, one thing I did want to point out is that, you were talking about maybe putting a sock on the testes or something.
Right.
Is that rats and mice actually get a very enviable deal.
How so?
They get what I call convertibles, which is to say basically they can tuck their testes up inside the body for safety. But on the other hand, they can let them hang out, and sperm are produced pretty regularly. So basically they can let them hang out when they want to reproduce. And, I can see human beings absolutely coveting that kind of a system, because you'd have control over fertility and safety at the same, it's not at the same time, but at choice.
In 500 years from now, Abby, I think that with the CRISPR technology, the gene splicing, gene manipulation, I think that could be a whole thing for men in a couple of 100 years.
Could be.
That's kind of spooky.
I'm sure there's a transhumanist somewhere working on it.
Right.
So tell me, are mud skippers the devil's fish? Because they seem very unchristian.
Especially because many of them are adorable. Yes.
So tell us about the odd case of the mud skipper.
The odd case of the mud skipper is a wonderful, wonderful fish that walks around on land. And in fact, it spends about 90% of its life on land, walks around, climbs trees. I'm not joking. This is a tree climbing fish. People sometimes find them on their garden sheds even. I have a wonderful picture that I found of a mud skipper standing on somebody's garden shed. But I mean, they routinely climb up small trees and mangroves and this kind of thing. So you have this walking, tree climbing, burrow digging, land nesting fish, which is a totally wonderful creature. And basically what happened to them is that they are intertidal organisms. So they basically live in shallow water. And when the tide comes in, the problem is that big predatory fish can come in along with the tide. And so these fish, by remaining on land, obviously avoid those big predators. And, they swim perfectly well when they feel like it, and walk around on land when they feel like doing that. And the thing is that in mangrove swamps, particularly, or in any vegetation that is intertidal, there will be literally trees and tree roots and what have you sticking up out of the water. And so from the fish's survival perspective, scrambling out onto a tree is a way of getting out of the deep water where the big fish are.
Sure.
And so it's a very good mechanism for avoiding predation. And so, yes, we have these wonderful, wonderful fish. They are Pacific fish. It's why we don't find them around here. But you can see them in various different places in the Pacific, and there are actually many different species of mud skippers. So they're found in Japan, and they're found in Thailand and lots of other places. And yeah, they're basically these walking fish, which are very unbiblical. Right. And of course, creationists, ever since evolution was discovered, people have had a lot of trouble with the transition from sea to land. Right. Because sea creatures do seem to be so perfectly adapted to the sea, and land creatures appear to be so perfectly adapted to the land that people have a hard time wrapping their minds around the idea of that transition.
Sure.
But in fact, if you have animals like mud skippers, which we do, they are basically the intertidal organisms that live in that transitional zone and do very well, thank you very much, and they are indeed walking fish. Sure. And I will say they're not the only ones. There are lots of nice videos out now where you can see basically shallow water fish, which rather than swimming along the bottom, which can, be difficult sometimes.
Sure.
They actually have some of their fins have slowly evolved into what amounts to little feet.
Right.
That they walk around on the bottom of shallow parts of the ocean on. And it's like, yeah, they can swim, but if they just want to move a little bit, very often they just walk around. And so you have, I one time found them by Googling fish feet. I found all kinds of really cute organisms. And those are actually, marine fish.
Mm.
But then there are also things that I have seen of both mudskippers and other fish, and I'm now talking about the other fish, that can literally climb up small waterfalls. And by waterfalls, I now mean sort of water flowing over a rock, this
Sure.
kind of thing. But nonetheless, I have, seen videos of these fish actually sort of suckering their way up these rocks with water flowing over them.
Wow.
And so, they have pretty strong adaptations to being on land in sort of transitional areas, yet they are clearly still fish. So it's very interesting.
What do you say to people who look at a fish that climbs up a waterfall and say, that is evidence for God's creation right there, because there's no way that thing could have just popped out of nowhere?
Okay, that's a very good question. And the answer there is you can show all of the intermediate steps that would help the animal to survive. That's one of the things that anti-evolutionists have the hardest time with, is the whole business that each individual step actually can be useful. So if you just have a fish that can scurry a little way up a rock, again, if you're avoiding predators, this can be a useful thing. Having just that little bit of extra ability to move around, transport yourself a bit further, all of those things help.
Right.
And it's just that, then I think that many anti-evolutionists have a very hard idea, or have a very hard time with the idea of time.
Oh, right,
a very long, long time. That basically, you have a situation like a flowing stream, and you have these fish that have some ability to scurry around in shallow water, and there are certain predation pressures that make it worthwhile. Well, in deep time, very often you may wind up with mutations like this. One of the things that has to be understood always is that this is dependent upon mutations. If the mutations don't happen, evolution doesn't go in that direction. Mm-hmm. But if certain mutations do take place and they're very beneficial, then those are the mutations that are going to spread throughout that fish population. So that's how it happens, but it takes a lot of time.
Right. It's not like an X-Men movie where people are just born with laser eyes or anything like that.
No, it's not design. And that's the thing that keeps coming back, is that you see all these weird things, and it is so clearly not designed. Many of them are cool. I mean, you see weird, wonderful things like mudskippers, and they're terrific animals. But on the other hand, if you were building climbing gear, would you really start with fish fins? You'd probably start with something that would, give you more bang for the buck earlier on. But fish fins were what was available evolutionarily speaking, so that's what they went with. But this is why you may see these fish some places, but not other places. And it's why you see some animals that are actually surprisingly poorly adapted to their environments in certain ways. I'm thinking now of cormorants. You've probably seen cormorants around where you live.
Sure.
These, big birds that spend a lot of time in the water, and they're good divers. And, they fly, they dive, they hunt for fish, all of this kind of thing. They float on the water. But it turns out that they are actually not very good floaters. They are not ducks. They do not have these oil glands that allow them to float indefinitely in the water.
Really?
So, yeah, it's really cool. So cormorants actually have to get out of the water and dry out sometimes, which is not a particularly good thing in a seagoing bird that hunts by floating on the water and diving.
No, that's bad.
nonetheless, it's what they're stuck with because that's the way evolution is. It's basically, if it's good enough that you survive to reproduce, then it's good enough. And that's very different from what you would see with intelligent design, where you would imagine the creator saying, let's rustle up some oil glands for these seabirds, will you? You know, the Cormorants have put in a petition that we're favoring the ducks.
Right.
And you don't see that.
No, you don't. So I was watching one of your videos, and I've become very, very jealous of certain kinds of jellyfish.
Oh, yes.
They seem to have a really good deal in terms of the lifespan.
They have an excellent deal. Yes, there is a type of fish that is known as the Immortal jellyfish. Turatopsis nutricula or Turatopsis dornii, depending upon who you ask. And they are very tiny. I mean, so small, it's not terribly surprising we didn't know about them until recently.
Sure.
But anyway, yes, these fish, once they were in captivity and were observed in aquaria, it turns out that they do not have to die.
Wow.
They can basically live forever. And, I mean, they can die. They can die by being eaten and things like this, and that's what happens to most of them. But on the other hand, it's not required that they die. Whereas with you and me, even if we don't die of a host of diseases and so on, eventually we're going to get old and we're going to die of something. It just appears to be biological reality.
Right.
Except that these particular organisms have gotten around it. So yeah, basically what happens is that they just kind of float along, living their lives. And if at any time they are actually threatened by starvation or disease or a wound or even simple old age, they can basically de-develop. They go back down to what's called a polyp stage, which basically looks like a blob on a rock. And then they redevelop into new immortal jellyfish. And so they kind of do this rejuvenation with multiplication. So, they de-develop down to a polyp, and then they send up multiple new copies of this little jellyfish. And so, they don't just have immortality, they actually have continuously restarting youth. I mean, they literally undergo rejuvenation. And, there are lots and lots of people who really, really wish they could do that.
Oh, yeah.
I mean, think how nice it would be to just say, I'm tired of being old. I think I'll be young again for a while.
The entire character of Doctor Who is based on that.
Because they get to regenerate. The Time
Lord regenerating thing.
They don't clone. They don't clone, mind you. But yes, they get to
no cloning.
But they get to regenerate, right? Well, this is the thing that I point out is that the whole idea of, eternal life or regeneration or something like that is clearly something we long for. There is so much in literature, in popular culture, in religion of us trying to beat death in some way. We are really bothered by the fact of death, and for perfectly good reasons. That, this is not only where a lot of popular culture, I mean, a lot of science fiction is based around that. Doctor Who is based around that. But so is the Epic of Gilgamesh, and so is the picture of Dorian Gray. And for that matter, so is the Bible, which promises us eternal life. It's life after death.
Right.
But, well, as Steve Jobs famously said, no one wants to die. Even people who want to go to heaven don't want to die to get there.
True enough.
But the thing is, many religions base a lot of their appeal on the idea that you can live forever. Just follow this religion and you can live forever.
Yep.
Because we've got the secret, we've got an in with God, and all you have to do is, jump through these hoops and then you can live forever. And so, this leads to serious philosophical and religious questions when you ask, okay, we have to jump through all these hoops to maybe live forever according to you, but we never get to actually check it out. But these jellyfish get to live forever now.
Like for real.
Like for real, right. And we can observe it in real time. What's going on here?
That's great. So whenever I talk to someone who has an advanced degree, I like to ask them about what their thesis was, because I get to learn about some really obscure stuff typically.
Well, this is pretty obscure too.
Good.
What I was looking at was basically alertness and attention in non-human species.
Interesting.
I'll back up and explain it to you this way. During World War II, particularly, there were a lot of new technologies that showed that watch standing, there were a lot of new technologies in which watching something was important.
Sure.
Mm-hmm.
You watched radars, you
Yep.
watched sonars, you had to pay attention. And what came out of these sort of long involuntary experiments that we had going on during World War II was that despite the best motivation in the world, people could not remain at their best in a watch standing task for very long.
Yep.
So if you had 2 hours of watching a radar screen, for instance, even with people who were incredibly motivated and they took their jobs very seriously, basically if you had a 2-hour watch standing time,
Mhm.
the first half hour people were very alert. The last half hour, people were very alert, and people were not alert in the middle.
That's really interesting, because that's the way, same way with telling a joke. Because I do comedy. So it's like people remember the beginning of a set, people remember the very end of the set, but really the middle, no one remembers whatsoever.
Oh, that's interesting.
Yeah,
Yes.
Yeah.
And this is the kind of thing that in your daily life you've probably experienced this if you've ever gone on a long car drive where it's like, 8 hours straight through. It can get pretty hard to pay attention, particularly if it's highway driving.
Sure.
Mm-hmm.
Whereas on the other hand, if you're driving in the city, it's almost like there's too much stimulation. So what it turned out was the case with human beings in watch standing is that basically if you gave them irrelevant stimulation, just whatever, listen to the radio, talk to somebody, look at pictures even, rather you'd think that would be contrary, but anything like that basically stimulated the brain, they responded more quickly and more appropriately during long watch standing gigs.
Interesting.
So this was a way of getting around this lull that always happens. And as I said, think about driving cross country. If you are driving cross country, if you're going on a long trip, at some point you say to your passenger, please talk to me.
Right.
I need to pay attention here and I'm having a hard time. Or you turn on the radio or you do something like that. Mm-hmm. Whereas then when you get to a city and suddenly you have a ton of stimulation coming in on you, that's when you say, okay, I can't talk now. Be quiet. Turn off the radio. I got to pay attention here.
That's
and
interesting.
That is because basically there is an optimal level of stimulation for the brain to be at its best.
Right.
And it's not too much and not too little, but sort of just the right amount. And what I did was that I dragged this into the rest of the animal kingdom. I looked at birds called Barbary Doves. And this was basically because in the animal behavior world, there was a lot of work on how animals spent their time. And there was a lot of work on what they call vigilance, basically watching behavior.
Sure.
And my thesis was that there was not necessarily a contradiction between needing to watch for predators and eating, let's say, or socializing, that in fact they could do both things at once and might even be better off for it.
Right.
Because you would be in a higher state of alertness by having the extra stimulation from, say, feeding or socializing with your flock mates rather than just spending all your time trained to the sky, even if you're really worried about predators.
Mm-hmm, mm-hmm.
So anyway, that was roughly what my dissertation was about.
Very interesting stuff. What were you going to say, Jack?
I was going to say that I have noticed that with me when I'm on the interstate and I get off on the exit, I turn the radio down.
Right.
Yeah.
That's it.
It's an automatic response.
Right. But that's what's kind of beautiful about that particular example is that, although there was a lot of information that came out of the military on it, it was then tested in all kinds of different situations. And of course, I found it in the animal kingdom, but it's something that when it's put to us that way, we intuitively understand that, we are more alert when we have some extra stimulation, basically.
Sure.
And that's also why, if you're studying, if there's something that's kind of rote, maybe you need a little bit of extra stimulation from time to time. But on the other hand, if you're working on some really hard math problems, that's when you say, stop talking to me. I need utter silence to work on this because your brain is occupied enough as it is.
So it's interesting. You have to have enough stimulation and for a sweet zone, so to speak. And that sweet zone changes determining on what kind of task that you're doing.
Well, because the task itself can deliver some of the stimulation. It depends upon how stimulating that task itself is.
Interesting. Well, I'm not going to bother my 14-year-old son anymore when he does his homework and he has the radio on, because that could be some boring homework he's doing.
It might be helping, yeah.
It might be helping. I just can't assume that it's a bad activity. So Abby, tell me about DJing.
Oh, DJing! My goodness, that was fun. That was a long time ago. I was a DJ in college, and this was during sort of the glory days of rock and roll and progressive rock, and I had a fun time doing that. But my programs also tended to be more sort of a little bit of everything. I wanted to make them different. So, there would be readings of short stories. There would be dramatic readings of longer books. There would be a mix of music. There would be kind of whatever I felt like doing that day. And I invited a lot of friends along. I mean, it was always planned. I had a plan for these shows.
Right.
And it involved something other than straight music. I did that all the time that I was in college, and that was a lot of fun. I had, the appropriate FCC license at the time, which sadly has long since lapsed, but, I was legal at the time.
You were legal at the time.
Right.
But there's podcasting now, so we don't need FCC licenses.
That's right, yes.
So, Abby, I'd like to ask this question of all of our guests. Is there anything that you have been dying to say, a question that you would like to have been asked now, but you have not been asked, anything you want to talk about?
Anything that I want to talk about?
Yeah.
Well, there are lots of things I would like to talk about.
You got a burning desire for anything?
Well, I think I will talk briefly then about denialism in general.
Oh, yeah.
Because basically the same tactics are used for lots of different good things. It is a way of denying science, which was invented by the tobacco lobby because they wanted to keep selling cigarettes, and they could only do that by casting doubt on all of the good evidence that was coming out linking cigarette use to cancer.
Yeah.
And so they came up with this essentially playbook that was very effective, where they would hire people with PhDs to be their front people. They would set up a quote-unquote research institute that was basically an office with good stationery, usually in Washington, D.C.
Right.
And they would go on from there, and their idea was simply to, when in doubt, cast doubt on scientific findings, smear other scientists, try to say, oh, there's uncertainty, or this person is bad, or this kind of thing. And it was used to keep people smoking cigarettes for a very long time here in the U.S. It was used, it is being used against evolution. It is also being used against climate change.
Definitely.
And it is perhaps at its most dangerous in that because it's climate change is real, climate change is dangerous. It will change the world and the way we live and the fate of the human race. And meanwhile, we have, various people simply saying, oh, remember, it's the same thing. Oh, the evidence is not clear. And they will come up with long, long papers about why it is not clear. And they will smear scientists. The guy who published the famous hockey stick graph about global temperature change and CO2 had an awful time. I mean, he was pilloried for a long time. He is doing okay now. Basically because the people who accept climate change and think it is important have rallied and protected him. Right. But this is a case where a scientist was very surprised when he discovered that his career was on the line because he published his findings and said what they meant.
Yeah. That's sad.
Yeah. He never expected to be a celebrity. Yeah. He expected to just be a scientist publishing his work, and that's not what happened. But it's because of this very well-developed playbook that was invented by the tobacco industry. And what's interesting is that some of the same people have been tobacco/cancer denialists and evolution denialists and global warming denialists. So they really are the same people doing the same things for the same reasons.
Yeah. Politics and money.
Right. Mm-hmm. And there's a lot of money in denying climate change, obviously, because the entire fossil fuel industry is against the idea of people understanding and accepting it.
Oh, yeah. Yeah. There are moneyed interests involved. There's no doubt about that.
Right.
Well, Dr. Abby Hafer, thanks for coming on today. Believe it or not, we're about at an hour. It was a fast.
Wow.
I know. Wasn't that a fast hour?
That was a fast hour. It was a lot of fun.
Yeah, I had a lot of fun, too.
I was riveted.
Oh, good.
We talked about devil's fish and immortal jellyfish and all kinds of testicle goodness.
Absolutely, yes.
The name of the book, again, is The Not-So-Intelligent Designer, Why Evolution Explains the Human Body and Intelligent Design Does Not. I suggest for all of our listeners to pick a copy of it up.
Thanks very much.
Yeah, well, thanks again for coming on. We had a really fun time.
Okay, great. Hope to talk to you again sometime.
Definitely. I'll be around.
Okay. Bye-bye.
Bye.
Bye.